We also have volumetric shadows. This is using, the volumetric shadows are using the stencil buffer shadows that people have seen in SIGGRAPH papers and things like that. If people were here for the advanced OpenGL session that Mark Kilgard and Michael Gold of NVIDIA did, he talks about the way that the traditional stencil buffer shadow stuff works. He does a slightly different version than what we're doing. I'll get into that in a second. So obviously, if these are called stencil buffer shadows, they're going to require stencil buffer. We would ideally like 8 bits. I think we can use 4 bits, but some artifacts will be introduced as a result. This is a second-tier feature, which means that when we were writing Quake III Arena, at no point did we go, okay, these are super important. We're going to have to make these run fast, look good, not have problems, have to run everywhere. Curved surfaces are a first-tier feature. Have to run everywhere, have to be fast, have to look good. Stencil buffer shadows are something that John basically put in there in a day just to see if it would work. And since it requires a stencil buffer, it basically runs on Rage 128, TNT, TNT2. I think it should run on Promedia 3, but I haven't seen it running on a Promedia 3. And it definitely won't run on Voodoo 2 or Voodoo 3 since they're 16-bit. Won't run on an Intel i740, or and actually won't run in 16-bit mode on pretty much any card, because if you even have stencil at all in a 16-bit mode, it's only a single bit. So let's see. This may be sort of difficult to see. So there, the quad damage is just casting a stencil buffer shadow straight down. The cool thing, it's actually self-shadowing, which may not be readily apparent there. So actually, the pieces of it are casting shadows onto itself, which is, you know, immensely cool. It's a subtle thing, but it is immensely cool. So the basic technique works like this. I'll take that off so I don't get dizzy. You go from the light source, and you determine the silhouette edges on the outside of the object. And this is basically how the one that Kilgard talked about works also. You take those edges, the silhouette edges, and you extrude those in the direction that your shadow would be going for a very long distance, and you make that into a quad. So basically, if you do this around the whole silhouette of the object, you should have like this, basically this extruded volume of the object of where it should be shadowing. You render all of the front-facing ones with your stencil buffer set to increment. You render all your back-facing ones afterwards with a stencil buffer set to decrement. Anywhere after that, and I know this is really difficult to visualize, especially with me just saying it and not, you know, preparing enough to like give you sketches and stuff. But even if you do sketch it, it's sort of like not intuitively obvious either. But the net effect of this is that wherever there's supposed to be a shadow, the stencil buffer will be non-zero. I mean, assuming obviously that you cleared it out beforehand. And so at that point, your frame buffer or your stencil buffer should be set to zeros for anything not in shadow, ones or greater for anything that is in shadow. So then when you're all done with that, you just take a very large polygon over the whole scene, you blend it, we use a fairly light gray, and you set your stencil test to greater than 0. Then magically, everywhere that there should be shadow suddenly has a shadow because you've blended this big polygon over it. To try and speed things up, I mean, currently this particular build is a few weeks old, so it's incredibly inefficient. That's the reason why a lot of the IHVs weren't showing it in their booths with the shadows enabled, because right now, like right here, we're actually going through and computing the edge connectivity every single frame for that entire model, which is really bad. We should pre-compute that. On top of that, the models have multiple LODs, and we're just using, like, I think the highest LOD, and that's really bad too. For shadows, you don't need that level of resolution, so we should be using the lowest LOD all the time. Once we go through and optimize it, because it's a sufficiently cool thing that we probably should optimize it, but we won't depend on it for gameplay reasons, then it should be significantly faster. But it's still, I mean, even no matter how optimized we make it on our end, it's still going to be fairly slow, simply because the amount of overdraw and the extra transformations that are required. So the advantages of going with a stencil buffer shadow technique is that it's better than analytical approaches, since it's actually just based on what you render into the frame buffer. An analytical approach, you know, something where it actually goes and does ray casts and tries to draw polygons that sort of go around the world, yes, would theoretically be better, but as our triangle densities just get huge, that's just not going to be a really, you know, it's not going to be a very tenable solution to the whole problem. You're not going to be able to ray cast against millions of triangles every single frame. This also allows for self-shadowing, which, as I mentioned, is fairly cool. What this does show is this disparity between regular Gouache shading and self-shadowing. The reason for this is that the shadows are basically based off of flat faces. Gouache shading is based off the vertex normal. So you get this weird transitionary popping thing where the Gouache shading, as an object rotates away from the light, the Gouache shading will smoothly transition. But since we're just looking at silhouette edges for objects that are stencil shadowed, it'll suddenly be pop when the silhouette edge pops up, and suddenly that entire face is going to be in shadow where previously it would be in light. One of the problems is that shadows can cast through surfaces right now. I talked to John last night, and he said that he fixed that, so I guess it's a fixable problem. I'm not exactly sure what he did, but such is, my life. I'm not going to whine to you people about it. All right, so, well, I already did. So it is expensive since you have to determine the silhouette edges, like I said. I mean, if you're implementing this naively, like, we are currently, then it is expensive. But if you pre-compute all your connectivity, your adjacency information, it should be a lot faster. It is expensive since it requires a lot of overdraw, both because of the quads and the final screen blend. And as I mentioned, it does exhibit the artifacts that I mentioned between Gouache shading, the inconsistency with Gouache shading.